Okay, so here's something else that I want to look at now. Let's say we are still looking at the same bug, and again this is the origin. Let's say now, so the bug is moving again, and the function f tells you the position of the bug at time t. Let's say at time a, this is the position of the bug, and at time b, now this is the position of the bug. So the bug, the beginning and the end positions are not the same anymore. So these are the positions. Can someone tell me what is the average velocity of the bug? What is the average velocity of? So I have a bug moving along the real number 9. The position of the bug at time A is f of a. The position of the bug at time B is f of b. Let's say a is less than b. Then what's the average velocity of the bug? What is the average velocity of the bug? Anybody? You have taken physics courses, right? So you know what is average velocity is. Yeah, the position at time B minus the position at time A, right? This is the net displacement divided by the length of the period, right? The length of the period is B minus A. So over that period, the average velocity, if I say that if you drive from Ada to Columbus, let's say that's 100 miles, and if it takes you 2 hours to get there, what's the average speed? If the distance from Ada to Columbus is 100 miles, and if it takes you 2 hours to get there, what is your average speed? 50, right? What did you do? You divided the distance covered over that interval divided by the length of the period. Same thing here. You look at the net displacement over that interval, time interval, divided by the length of the period. That's the average velocity. Okay? Now, the same assumptions as before. The motion is continuous. The velocity is defined everywhere. That is, nothing bad happens, right? Then, this time you can show that. So this time you can show. Okay, under those assumptions, we could say that the instantaneous velocity of the bug, the instantaneous velocity would be given by the derivative of the position function. The instantaneous velocity of the bug must be the same as the average velocity at some moment c in that interval. So there is a moment c in that interval where the instantaneous velocity must have been the same as the average velocity. In other words, if you go from here to Columbus, right, and if your average speed is 50, then wouldn't you agree that at some moment during your trip, your speedometer said your instantaneous speed was 50, right? Wouldn't you agree with that? That's all this is saying, that if your average velocity is something, then the instantaneous velocity must be the same as that at some moment. Am I making sense? So in other words, the average velocity over a time interval is equal to the instantaneous velocity at some moment in that interval. That's what we are saying here. Is that making sense? Well, I'm not going to give you a proof of this the way I did it for the where we showed that the velocity must have been 0. So I'm not going to give you a proof in this case, but let me tell you graphically what it means. So let's draw a possible graph of the position function and see what this means in terms of the graph. So let's say I have my x-axis, y-axis, let's say this is time, and let's say this point here is a f of a. So this is the point at a, and this is the height of this point is the position at time b, and let's say the graph looks like the following. Okay, and what is the average? What is the average velocity then over this time? So this is the graph of the position function, right? This is the graph of the position function over the time interval from a to b. Can someone tell me geometrically what does the average velocity represent here? Geometrically, what quantity is represented by the average velocity? The average velocity represents a geometric quantity in terms of this graph. What is that? This is if I look at the line segment joining the 2 points. So remember, this is the point a f of a, and this is the point b f of b. What is the slope of the line joining the 2 points? Well, it's the rise over run, right? F of b minus f of a over b minus a. That's the average velocity, right? And we are saying that's the same as the slope of the line segment joining the points a f of a and b f of b. And notice what we are saying then is that there are points in that interval where the instantaneous velocities are equal to that quantity, right? In other words, see, there is a point here where the tangent line is parallel to this line segment, and possibly there is another point here where the tangent line is parallel to this line. So this is a possible value of some C1. This is a possible value of C2, and what we are saying in this case, f prime at C1 and also at C2, they are both equal to this slope, right? So the mean value theorem is telling you exactly that the instantaneous rate at a moment c is the same as the average rate of the function over an interval. Does that make sense? So for any function, I can say the average rate of a function over an interval is the same as the instantaneous rate of the function at some moment in time. Or I shouldn't say time if for any function, but at some moment in that interval. So that's exactly what the mean value theorem says, that if you look over an interval from a to b, if you look at the slope of the slope of the line segment joining the points a f of a and b f of b, then there are points on the graph where the tangent lines are horizontal to that. So the slopes of the tangent lines at C1 and C2 are equal to the slope of that line segment. You guys see that? So what is the mean? I keep saying mean value theorem when I didn't tell you mean value theorem, I guess. But this is what we are saying with the average velocity case. So let's look at what is the mean value theorem. I already have written that down. This is the mean value theorem. So the mean value theorem says exactly what we have just said for any function. Remember what we said for the bug, that the average velocity of the bug over the interval from a to b is the same as the instantaneous velocity of the bug at some moment c in that interval. This is the same thing for any function. F is a continuous function, differentiable function on the interval from a to b, and what we are saying is that the average rate of the function, this is the average rate of the function, okay, is equal to the instantaneous rate of the function at c. Okay, the average rate of the function is equal to the instantaneous rate of the function at some moment c. Is that Is that making sense? Okay, any questions? Anybody? Any questions? Okay, so we will see how to use this theorem in a second. You guys are done writing it down? Okay. So let's look at an example. Okay, so this is the example that I want to look at. Suppose that I have a function f, and f of x is the function x cubed minus 15x plus 8, where x is between -2 and 2. So we are considering this function over that interval. The first question is, does f satisfy all the hypotheses of the mean value theorem? What are the hypotheses of the mean value theorem? They are: the function is continuous over the given interval, the function is differentiable over the given interval. So you want to ask yourself, is this function continuous? Is this function differentiable over from -2 to 2? The answers are yes and yes, because it is a nice function, right? It is a polynomial function, right? And we know that polynomial functions are continuous everywhere, differentiable everywhere, so that's true. You don't have to do much for number one. You just have to say yes or no, whichever you think. Number two says, well, if you think it satisfies all the hypotheses of mean value theorem, find the moments in the interval where the instantaneous rate of the function is the same as the average rate of the function. Am I making sense? So the question will be phrased in this way: find the values of c satisfying the conclusion of the mean value theorem. What's the conclusion of the mean value theorem? That the average rate over the given interval is equal to the instantaneous rate at some value of c. You have to find that c. Is that clear? Is the question clear to you? Let me know if you're done writing the question down, and then we're going to go over the solution. Now, I have asked this question in exams many times for many years, and I've seen that a lot of people they don't do this problem correctly in any of those exams. Okay, and I always ask myself why. The reason is there are only two types of questions that I can ask from this section, and this is usually the one that I ask, and I actually tell students that this is usually the one that I ask, but every single time for some reason students miss it. Okay, but if you sort of think of it a little bit, you'll see that this is not really a difficult problem. There are no difficult computations in it. Okay. But if you, of course, don't practice the homework problems, then you might not remember how to do this. Okay, so how do I find the values of c satisfying the conclusion of the mean value theorem? Well, f prime of c is, what is the average rate of the function? What is the given interval? The given interval is from -2 to 2, right? So what's the average rate of the function over that interval? The average rate would be the value of the function at 2 minus the value of the function at -2, right? Divided by 2 minus -2, right? You look at the value of the function at the right end point minus the value of the function at the left end point, divided by the length of the interval. The length of the interval in this case is what? 4. It's negative 2 to 2, so the length is 4. So divide the difference of the values at the endpoints by the length of the interval. That's the average rate of the function. What does mean value theorem tell us? Well, the average rate is equal to the instantaneous rate at some c, right? So this is what we have to solve. We have to find values of c for which f prime of c is equal to the average rate. How do I find c? Well, first of all, in this case, what's the average rate? You'll see that f of 2 is negative 14. You'll see that f of negative 2 is 30. So this quantity comes out to negative 11. So the average rate of the function is negative 11. Now, so we want to find values of c for which the derivative is negative 11. Well, what's the derivative function? We know the function is what? X cubed minus 15x plus something, right? 8. So what's the derivative? 3x squared minus 15. So plug in c here, what do you get? If you plug in c, you get 3c squared minus 15 is negative 11. And then it's just a matter of solving for c, right? This is just a baby algebra, right? You just solve for c. And in this case, when you solve for c, what do you get? You get plus or minus root of 4 divided by 3. And you have to ask yourself, are both values inside the given interval? Well, I think both of them are in the given interval. And so you have two values of c where the derivative is equal to the average rate of the function. Am I making sense? So you just have to set up the equation that the derivative at c is equal to the average rate, and then you solve for c. Derivative at c is equal to the average rate, and you solve for c. You can remember that? Okay, so that's one example of problem that you may see in quizzes and exams. Okay. Any questions at all? Everybody is okay? Okay. Another example. Suppose that I have a function, so if f is continuous on an interval from a to b, and if the derivative of the function is 0 for all x inside of the interval from a to b, open interval, then prove that the function is a constant function. Then prove that f of x is a constant for all x in the interval from a to b. Am I making sense? Of course, intuitively remember, if the derivative is 0, we know that the derivative gives you the slope of the tangent lines. Basically, we are saying at every point, the tangent line is horizontal, right? At every single point, the tangent line is horizontal. Intuitively, you agree that the graph of the function should be a horizontal line, right? So but how do I prove something like this mathematically? Well, we're going to use the mean value theorem. In order to show that the function is a constant function, do you agree that all I have to show is that the value of the function at any x is the same as f of a? If I show you that f of x is equal to f of a for any x, wouldn't you agree that the function is function is constant? At any x, the value is the same as the value at a, right? So that's what I'm going to do. So let's apply mean value theorem to an interval from a to x. So by the mean value theorem applied to this interval from a to x, so I'm picking any x between a and b. Okay, so between a and b, I'm picking any x. So I have let's say here's a and here's b, and I'm picking any x in between. What does the mean value theorem tell us about this interval? Well, what's the average rate of the function over this interval? What's the average rate? F of x, f of a over x minus a. That's going to be the same as the derivative of the function, or the instantaneous rate of the function at some number c, where c is where? Where c is between a and x, right? So c would be somewhere here. But what is our assumption in the problem? The assumption is that the derivative is what? 0 everywhere. So this derivative is 0. So if this ratio is 0, what is 0 then? The top is 0. Well, if the top is 0, then we know that f of x is f of a. Am I making sense? So what we have shown is that for any x, the value of the function at x is the same as the value of the function at the left endpoint, which means the value of all the values of the function are the same, right? Over this interval. You guys are okay with that? So it's a constant function then. So what is the value of c then? The value of the constant is basically the same as f of a, right? So f is constant. So f of x is a constant for all x in the interval from a to b. Okay? You guys are okay with that? Any questions? Anybody? No? Okay. Today I'm going to assign a new homework on WebAssign, and which will be from section 3.2. Friday your quiz will be over 3.1 and 3.2. Okay. So look for an assignment on WebAssign tonight on 3.2. I already gave you a homework on 3.1 before, right? Okay. I'm actually going to stop right here, okay?